Good morning. I wanted to start this video off with something a little strange. Um, I thought it was a great humorous steal off of social media. See, that's a little strange. That's actually Doctor Strange, but he's little. See, get that? Okay. All right. We're gonna do inequalities today. We'll put the strange things away. We're gonna work on this worksheet, which was actually yesterday's work, and the other one together because we've had a few um, questions about inequalities. And I think you need a little video for this. I thought that maybe reading this information that's in front of you right now might help. Um, but as I read through it, I understand why you might get lost in there and get a little confused. So I'm gonna share some things that I know about it, and then we'll do a couple examples and try to fill in some blanks there. And if you miss something or you need to, please email me, um, and we can get caught up on that. Uh, so I do want you to take time to read the beginning. That's why I give you this worksheet with the reteach, is so that you can see this information and then refer back to it. There's some important points here in the middle. We'll start off with the fact that I know that paper is called Inequalities, but there's a thing called Equalities. We don't use that word very much because we just call it equal in mathematics, or we call it an equation. So you can see that I've gave you a definition here. Equalities are basically things that are the same. In this case, mathematics, we've got 1/2 is the same thing as zero point 0.5. They don't look the same, but they have the exact same value. That's what separates math from other definitions of the word equality. 50% is the same there. X could be equal to 4. In this case, when it's written this way, someone is stating that it most definitely is 4. It's nothing else. X is 4. That doesn't mean in a future problem that X couldn't be something else. We've seen this since early on. 2 plus 3 equals 5. The equal sign is something we're very familiar with. You have, again, an exponent and its whole number representation. These are two different ways of saying the same thing. This is a not complete or reduced problem, and this is a problem in its simplest form, or this is the number in the simplest form. And then you have what's a true equation. True equation pits a variable with some kind of operation in it, a variable against an equal point. And so this is an equation. Sometimes it can look as simple as x equals y, which means those are the same. So um, equalities are equals. Equations and solving equations is where we've worked with equalities. But sometimes you have some cases where you don't know the actual exact number, and so you would say things like, for instance, I'm going to the store and I need bread, milk, and a bag of potato chips. So I know that's going to cost at least $10. Well, at least is an inequality. You know that it's going to be $10 or more, um, and so an inequality means you're not representing it in an exact value or one point on the number line. So inequalities are like or inequalities are things that are not equal. I broke the word apart here. You've got two words. Of course, you got your root word equal, which means the same. The equalities part, the suffix end of that is the plural, and that's applying it to the situations that are at hand. But N is a prefix meaning opposite or not, such as the word incomplete, or I don't have any good the other good examples right now, so please feel free to comment some good examples of where we use the word um, or the prefix "n." Things are not equal. You can use an inequality sign or an unequal sign. That means it's not equal. Here's a question for you, and I don't really know the answer, but I suppose this might be an inequality. The question is if it is. This is an approximate sign. So if you have something that, let's say, a sixth grader's age. So the age of a sixth grader age is approximately 12 years old. We know that most sixth graders turn 12 within the year that they are sixth graders, but sometimes they're 11-year-olds and sometimes they're 13-year-olds. So the approximation sign, that's kind of a separate side. We have to discuss whether that's an inequality or not. There are exact inequalities. There's not. That's the wrong word. There are some symbols that mean inequalities, and you're familiar with those as well. You've got less than, the less than symbol, and then you've got the greater than symbol. And when we're in class, and I think we've already done this year with both classes, but when we're in class, I always ask the question, how can you tell which one's which? How can you tell if this is a less than sign or a greater than sign? And I always get the same response, and it's always not the answer to my question. A lot of kids say, well, that's always pointing the alligators eating the bigger number. So if I have 13 and 12 on this side, it has to go this way. Yeah, but that's not the question. The question that I'm asking is, how do you know that that's a less than sign? That's pointing the right direction. I know that it's Pac-Man eating the bigger number, it's the alligator, or it's pointing at the small number, the small ends pointing at the small number, the big end, big opened ends open. There's lots of ways to remember that. The way that I use to remember that this is called a less than sign is that this looks like an L. It looks like an L for less than. Okay? Or you can, since we read left to right, you can envision the fact that this side right here is less than this side right here. And so you can remember it that way. Same with greater than. Greater than, it's greater on this side than it is on this side. So there's two different ways that you can use to remember which one's which. Kids like to, they don't like to, but kids panic when I ask questions or have them do that on the board, and I say, okay, read this to me where it's x is less than 4, and they're like, x is that symbol 4. And you shouldn't have to panic. You should have this little thing of it. The L is less than, or some kind of trick to know that that's the less than sign. Greater than, let me just represent that here. This time I'd have the 13 on the other side, then the 12. 12 is less than 13. 13 is greater than 12. Both of those statements are true, and so that makes it that way. Sometimes, though, you need a little bit more. You have a less than, but you also need to know that it could be equal to that. So if I buy bread, milk, and potato chips, it could be $10 even. It's not likely to be, but it could be exactly $10. But it also could be more than that. So it's the purchase. I'm using the wrong one for my example. The purchase of the chips would be, so let's call it purchase of the milk, bread, and chips, would be greater than or equal to $10. And that would be how I would buy that. If I take a $10 bill to the store, there's only one option for me. If it's exactly $10, I can get it. But past that, because it's more than 10, I can't. In this case right here, if the purchase is less than or equal to $10, I can take $10 and buy anything I want, as long as it's under $10. Okay, we'll look at those a little bit more. Now, on the paper that we're working with today, it's going to ask you some questions. Oops, that's the wrong one. That's actually the one that's due today, or that's you should be working on today. So here they've got solutions of an inequality. So this is when you're actually talking about what that value is, and you're maybe giving a target for that. So let me pull off an example from somewhere. Let's just use our 10 as an example. If you have, we need a new sheet of paper here. Okay, if you have P is less than or equal to 10, okay, let's put this in a real life situation. Grandma gives you $10 to go spend at the store, at the quick shop, and you have $10 you can spend. So you can spend all of that $10, or you can spend $3, or you can spend $5, or you could spend $7.38, whatever. But you cannot spend more than 10 because that's all that you have in your pocket. So your purchase has to be less than, or it could be equal to 10. So this is less than or equal to 10. This is the mathematical representation of that sentence. So your purchase is less than or equal to $10. All right, that's the English version of this mathematical statement. Okay, and then you can actually plot this out on a number line to show what we're talking about. So here's a number line, and on all number lines, I think it's a good idea to have three. For today's lesson, we'll just start with zeros always in the middle, and then you can put your two opposing, your 10 and its opposite on there. There's 3 points. Just looking at this, I can see that this is a little smaller than that, but that's not a big deal. We're not going to worry too much about how exact your drawings are. These are just sketches. So 10 is our target. We know that 10 is how much money you have in your pocket. So I'm going to circle that. That's our target for 10. But you can spend less than $10. Now, because we're talking about money, there's a little caveat here that we'll talk about in just a minute. But it says you can spend less than or equal to $10. That means my solution, or what I spend, could actually be $10. So when we have this equal to, we shade in that circle. It's called a closed circle. Okay? And then we want to represent all the other things it could be. Could you spend $11? No. Could you spend $9? Yeah. You could spend 9, you could spend 8, 7, 6, 5, 4, 3, 2, 1, 0. You could spend all of those values. So you shade in that part of the line, put the little arrow that indicates that it's going that direction, and this means you can see that highlights it so that I can see one pencil mark versus a bigger pencil mark. I can see that you're going the direction that you need to. Now, because we're talking about money, and now this equation didn't give us a dollar sign. If it did, we would have to stop right there because you can't spend negative money. You can go up to the counter and she says $11, and you say, well, I've only got 10. Well, then you're going to have to put something back. So in our situation, we wouldn't go past the negative, but almost always on these assignments, you're going to include everything less than 10, because negative 100, way out here somewhere, is less than 10. So that's what we would do. We'd put our line out here, shade it a little bit bigger, and put our arrows out here. Okay. For a real life situation, we'd have to consider some other alternatives, but we're just practicing with inequalities. All right, quick summary. Inequalities mean it's not equal, but this inequality could share that it's equal. So this is equal to 10 or anything less than that. Okay, let's do one going the other way. And we'll pick a random number out of the sky. So I'm going to go with the variable m, and it is, by the way, they use cursive letters for variables a lot. So that's what I'm going to do. And it's going to be just greater than, and we're going to use, we can use any number we want, so we're going to use 44. Okay, m is greater than 44. So on our number line, we have to know that the number 44, let's say it's right over here, okay? This is one of those where you may not want to use opposing ones. You could put a 0 and a negative 44, but that doesn't really serve a big purpose here. Let's just put the 0 over here and 22 over here. If you wanted to, you could put 66, because I'm going by my interval of 22, but this is good. Our target is 44, so we're going to circle 44. Now, could it be 44? No, it can't be 44 because it says it's only greater than 44. Okay, in this case, greater than 44 is over here. So even though I planned out, or I didn't plan out my number line, even though I drew all this over here, I'm not actually going to use it. What I'm going to do is circle the 44, and then I'm going to go this direction with my arrow. Because if m is greater than 44, that means it could be 44.1, it could be 45, 46, 4,000, anything. According to the conditions I've placed on m, it can be anything except for these numbers here. It can't be anything 44 or below. Okay? Real life situation, or sorry, the English translation of this is m is greater than, you could write more than, greater than 44. Okay? We just simply have an inequality, which happens to be greater than, and then we plot it out like this. Okay, so there's there's 4 different ways you're going to be plotting these. You've got a closed circle and an arrow going this way. That's a closed circle. You've got a closed circle and an arrow going this way. Or you've got an open circle with the arrow going this way, or an open circle with the arrow going this way. In this case, this means that it's equal to that, and it's going to be on this side of the number line, which is greater than. So where this is going to be a greater than or equal to graph. This one right here is going to be a less than, because it's going to be anything such as this one, less than here, right, on this side, less than or equal to, because it's closed or shaded in. That means it could also be equal. It can't be equal here, but it's going that way, so it's just going to be greater than. M is greater than 44. We had an open circle, and we had the line. Here we've got an open circle, but it's going towards the less than side, so we've got it there, right? This is a top secret, not a really secret, but here's something that I can point out to you. If your variable is on the left side, as long as you've got this written like this, then this line always goes the direction that the less than or equal to, or the greater than symbol, the inequality, is pointing. Okay, so you can see that this is pointing that way. That's how your arrowhead's going to be. Okay, this one's pointing this way, your arrowhead's going that direction. That works always if the variable is on that side. If you get one where the variable's not, I'm not seeing that on your homework, but if you get one where it's not, then that is something that you can change. You can use the reflective property. If you have the value s is greater than or equal to 4, that's correct. If you have n, sorry, I keep putting it on the wrong side, 3 is less than or equal to n, then you can flip that around. But you have to make sure you do that legally. N is the bigger number, right? So you're going to put the n over here, and that flips this sign around. So you've got n is greater than or equal to 3, which happens to be the same thing as 3 is less than or equal to n. Okay, so that's one of those little tricks that, as long as you're following the same format, this directional trick can help you every time. If we were in class, I'd probably hand this out to you to put into your notebook. I didn't include this in the packet. I think once you do have this on the top of that assignment, and I think once you work on it a little bit, you'll know all this anyway. So this is the inequality symbols here, and then the inequality symbols with their graphing, how to graph them, that we just went over right here. Okay, so let's look at a couple examples from the homework. We'll start with number 1 on this first page. It's the Reteaching 12-2. And on number 1, we're going to graph the inequality. And they've told us to answer these 3 steps. So this is kind of setting us up for the solution here. Okay, they've given us a number line, and that's pretty nice. Graph the inequality x is less than or equal to -4. Write the inequality in words. Okay, x is the first thing, so we can just write the x, and we're going to write is less than See, it looks like a little L there. I know that's kind of hard to see. I can maybe make that just a little bit bigger. X is less than, but I also have to say or equal to. And then the number is -4. -4. So, will the circle at -4 be open or closed? Well, in this case, it's equal to, so we have to close our circle to indicate that it's going to be part of -4. -4 is part of the solution. So it will be a closed circle, and then it says graph the solution. So if it's a closed circle at -4, I found -4, that's my target. I'm closing in the circle, and I've got to go less than. Now back to the little trick here. It's going this direction. This is the arrow going this direction. So I draw my line going right here. Okay. And we're done. We're done with that problem. All right. If you tried this yesterday, I hope that went well. The questions that I got had more to do with the opened and closed part. And then people asking me what an inequality was. But I hope that I've explained that thoroughly. Okay, let's go on to today's work. That's this practice 12-2. So yesterday was the reteaching. It had 3 problems, 3 each. So that's like 9 answers that you had to deal with yesterday. I bet that's manageable. And then today's it's a few more problems. You've got 17. Let's see. It looks like one of them has 2 parts, but some of them you have to graph them. The nice thing about this is they've given you the graphs already, so you've got this number line. And for those of you that have been confused, I apologize. I should have mentioned this earlier. The graph of a inequality or of a single solution like this is always a number line. There's only one dimension. So in the past, when we've talked about coordinate planes or graphs, a graph paper has 2 dimensions. It has a vertical and it has a horizontal. For a number line, it's just a horizontal, although you can certainly do a number line vertically, but that'll come up later. All right, so x is less than or equal to 3. Our target's 3. Find the 3. Is it going to be closed? Yeah, because it's equal to. So I'm going to close in that circle. And then I'm going to go the direction it's pointing. It's going to be less than. That means it could be 2 or 1 or 0 or anything in between. So I'm going all the way down. Anything in between or beyond. I didn't go all the way, but you can if you want. And that's a proper way to graph that inequality on a number line. Okay, I'm not going to write this one down, but if you look here on 4, you've got m is less than 50. Here's your 50. It'd be an open circle, and you're going that direction. Okay, variables are on the left every time. We can use the trick. Now down below here, 5 through 10, it gives you a solution. Now you don't have to graph or anything. You just have to decide whether this is going to be a solution. So the very first one, they give you x is less than 7. Does that mean x could be 7? No, it can't be, because x has to be less than 7. If it's $7, it's out of that condition. It's out of that range. So that's not going to work. So we would say no. No, it can't be a solution. Okay. Here it says p is greater than -3. Well, is 3 greater than -3? You can use your little substitution. 3 is greater than -3. Well, no, -3 is the smaller one. That doesn't work. So 3 is greater than -3. I said no, but look, that's definitely true, isn't it? 3 is greater than -3. Okay, so that's a yes. All right. 11 and 12, you're making your own inequality like this, but you're using these numbers. You should know that the target number is 30, and they've closed it in, and it's going this direction. So you get to pick your variable. I think that's right. Yeah, you get to pick your variable. A lot of times people like to use their first initial. I did earlier. Or you can use something generic like n or a or x or y. N's relationship to 30. The relationship to 30 is that n is going to be less than. It's going to be -10 or 0 or 10 or 20. Any of these would work, right? Does it include 30? Yeah, it does. It includes 30 because it's closed. So n is less than or equal to 30 for number 12. Okay? These real-world statements are questions like, for instance, I gave the one about sixth graders are approximately 12 years old. 200 probably doesn't work well for age, but if you're looking to spend money on a used bike or something like that, you're looking for a bike that's less than $200. So you would just write that real quick. The purchase of a bike should be less than $200. If you save up $200 for a bike, you want one that's pretty good, and you may have to pay up to $200. Okay. Write and graph an inequality for each statement. This is just using the real world sentence and putting it into the equation. These are your target numbers. They're all on the list. 150, 150 is right here. And then the last one, if you can say this 3 times really fast, I'm impressed. You don't win an award or anything, but I'm really impressed. And then you can finish that one out. I don't think this assignment will take you very long. The hardest thing about it is switching to your mindset of where things aren't equal. You don't have an actual solution or a one solution. You have a solution that involves a range of numbers, such as everything less than 200. Okay. If you have questions, feel free to email me. That's where I end it for the day.